My name's Joel Mills.
My name's Yasid Jayasinghe.
My name's Joel Ravi.
My name is Sarah Salmon, and we are AetherTech.
My idea for this project was that we were commissioned to design and build a indoor dirigible that was capable of carrying a load and maintaining flight for at least 60 minutes.
And had to be controlled and easy to fly.
My responsibilities for this project included the design and manufacture of the gores that we used to manufacture the balloon.
My contribution to this project was primarily in the propulsion system, where I designed the attachment for the motors powering the blimp to the servos that would change the direction.
So my contribution included working on the landing gear. So the landing gear was designed to protect the airship, any of the components that were used, the hardware, as well as the propellers to make sure they didn't strike the ground. As well as responsible for the skin of the airship, so deciding which material would be used.
The main component that I designed was the cargo bay. While it seems like a very insignificant part, it was the connection point between all the other subsystems in our project. The biggest challenges I faced in the cargo bay was to make it light, but also let it be flexible in the case that we needed stability and ballast added. To manufacture the cargo bay, I used laser cutting of balsa wood originally. The issue that arose with that was the dimensions for the balsa wood did not fit into the specifications we needed for the cargo bay, as well as the fact that balsa wood was far too flexible for the load it was being put under. As a result, plywood was the new material of choice.
The parts I worked on were basically the airframe initially, when we had the idea of constructing a rigid airframe to support the balloon and the components that the dirigible would carry. As we went on with the project, we realized that this was not a very feasible endeavor, so we scrapped it because of the weight contribution. And then towards the end of the project, I was given the responsibility of coming up with the dimensions for the gores so that we would be able to fashion a efficient and well-structured balloon. So to get down to the bare bones of the manufacture of these gores, they were based on a graph that we drew that resembled a ellipsoid function across an x-axis. This was the profile of the gores that we were going to use.
I designed the arms, as earlier stated, connecting the thrust vectoring servos to the motors spinning the propellers. The method of choice for this project, this part of the project, was 3D printing. We got such flexibility out of 3D printing that it just met our needs perfectly.
So I was responsible for working with the landing gear. So the landing gear went through a number of design and prototyping stages. It started with being 3D printed. At first, the landing gear were going to be like tripod legs, as similar to what you could find on common drones. But then after realizing the sheer size of the blimp, we decided to go for a more skid or ski-like design. In addition to this, I was responsible for the skin. It initially started off with being made out of Mylar emergency blankets and being heat sealed together. We realized that it was not able to retain air and would deflate and lose most of its volume within the first 10 to 15 minutes. So we decided that we were going to make a new balloon. The next prototype of the balloon was created with garbage bags and was sealed together with tuck tape. And this balloon maintained more of its shape and was much more effective in retaining air.
As a system, in terms of test results, the hybrid airship did quite well. Personally, in terms of individual components such as the cargo bay, even after it was stripped down due to weight issues, it did perform well. It held all its components well and protected the payload.
There were no visible defects that formed. The whole structure actually was able to absorb a good amount of impact and still retain its relative buoyancy and not really disturb the internal components too much. So that was a good aspect of the design that we saw on test day, because it complied with our criteria of making it a safe device to fly.
We decided to test our battery capacity by running the propeller motors on full, which we think was our limiting factor in terms of battery life. And they lasted about 3 hours, exceeding the 60-minute minimum set out in the challenge.
The balloon was able to fly and have motors that turn in 360 degrees. This was effective because we had really good control of the blimp, so we could move it upwards, downwards, hold it at a steady altitude, turn on a dime, turn a large circle, a small circle. So this was really effective in regards to how busy the presentation day was. There was a lot of people and a lot of blimps in a small area, and this allowed our blimp to safely avoid other ones.
So overall, I do believe presentation day was a huge success. The RC controller worked as need be. The blimp did fly autonomously for a good period of time. A lot of the autonomous features that we did program and the software components worked quite well. Moreover, during the obstacle and racing challenges, we did perform quite well and even ended up beating another blimp.
Our presentation day was a great opportunity for us to show off and be proud of the work that we'd accomplished together as a team. I think in the last moments we really pulled together and put together something great.
I believe this project was, in my opinion, a very good reflection about what we've done over the past over our first year in engineering.
I really enjoyed that we were able to take the physics that we were learning in class and to apply it to a real-life application. Also, what I thought was really good about this project was that we all really shared this love and desire to learn about aviation. Our group really worked well that way because we all had a passion.
I recall on our demo day, Joel and I were refilling our balloon about halfway through, and one of the co-op students from the MME clinic told us that he saw our team together and it looked like we were having fun. This kind of amplified in my mind my perspective on the project. I really do think that we enjoyed ourselves on this adventure.
Personally, what I learned was that no task is impossible. If you have the drive to do it, and if you have a clear vision, a clear goal in mind, you definitely can.
From a personal perspective, I had no understanding of fluid dynamics or aerodynamics in general. In terms of manufacturing of balloons, I've never had experience in that field either. So this project did push us to learn new things, it developed old skills as well as implement new ones. And most importantly, I think it taught us how to work with passion and pride.
From this project, I'd say I've gained purely experience in the most general sense of the word.
If it had to come down to one thing that our team as a whole could have done better, is probably just to stick to one schedule.
We should have had a more detailed schedule during the first few weeks of the project. We did have a far-reaching schedule originally.
The only problems were sticking to that schedule that we had in mind. But I feel we had the right idea, and if we were able to implement that in a more efficient manner, then we would have probably got a lot done a lot faster and had more time for testing and analyzing the results and possibly making some improvements.
In my opinion, the things that could have been done better were to rectify the oversights that we made during this project. We focused a lot and over-engineered many of the individual components, such as the thrust vectoring system, as well as the holding bay.
For us, at the beginning in our design manifesto, we stated to keep things simple. But throughout the majority of the design process, we didn't exactly follow that. We kind of went more in depth and we over-engineered some parts. But we really could have just stayed true with that, keep things simple, and we ended up going back to that right towards the end of the project.
I think the best way to sum up this project was it was a reassurance, or rather a reinforcement, that we knew what we wanted to do. I believe engineering is a very vast and distinct field. It's quite confusing when we first came into 1A if this is exactly what we wanted to do. And I think through the process, through the design process, through the manufacturing process, and through building the hybrid airship that we did, the Red Zeppelin as it was colloquially named, I think we all reinforced the fact that we truly did love engineering. We were in the right place at Waterloo, and we knew what we wanted to do.
Innovation, aesthetics,
functionality,
Speed,
safety,
simplicity,
fun.
AetherTech.